Okay, so in this question we need to prove the formula for cos 2 theta, then sin 2 theta, cos 3 theta, as in the double angle formulas, the triple angle formula, and then we will solve part D and E. So for part A, since we need to prove cos 2 theta, so I will use this formula, and instead of A and B I will use theta, so that theta plus theta will give you cos 2 theta. Okay, so let's start. So this is the formula: cos A plus B, cos A cos B, sin A sin B. So in this one I am just replacing A and B by theta. So the final answer will be cos theta plus theta at the left side, and this A and B you need to replace them. So from here at the left side you will get cos 2 theta, and since they are multiplied together we will have to write cos square theta. Similarly, since they are multiplied together, it's sine square theta. But the final result has to be in terms of sine square theta. Sorry, the question actually asked for cos square theta. Okay, so it's just that we need to replace sine square. So the next line will be cos square theta 1 minus cos square theta. So cos square theta minus 1 plus cos square theta, so you will get 2 cos square theta. Sorry, I actually converted the whole thing into in terms of sine, but it is supposed to be in terms of cos. Okay, in terms of cos. Okay, so we are done with part A. Cos 2 theta is basically 2 cos square theta minus 1. So that's part A. Next, for B, we need to prove sin 2 theta equals 2 sin theta cos theta. So double angle formula for sine. So sin A plus B is this one: sin A cos B, cos A sin B. So in this one, if I replace A, B with theta, you will get this result: sin theta cos theta sin theta, which is eventually the same thing. So if you just add them up, you will get a 2 at the very beginning. So 2 sin theta cos theta. Then for part C is the triple angle formula for cos 2 in terms of cos. Each and every single term is in terms of cos. So I will use this one, and since we need 3, so we can use theta and 2 theta, so that overall we get 3 theta at the left side. Okay, so for part C, this is the formula of cos A plus B, the compound angle formula. So let A equals theta and B equals 2 theta. So each and every single values will be changed. Like this one is theta, 2 theta. This A is replaced by theta, 2 theta. So you will just replace A and B in this equation. And then it's cos theta, cos 2 theta, sin theta, sin 2 theta. But the thing is, if we actually look at the last line, this is what we need to show, right? So each and every single angle is actually theta. So you cannot have any double angle or triple angle here, and all the terms has to be in terms of cos. So whatever we have, we need to convert them into in terms of cos. So sin 2 theta can be replaced by its double angle formula. We can use this one. And cos 2 theta, we can replace this one. This is the formula for cos 2 theta. So we are just using the formula from part A and B. I am replacing cos 2 theta using this one, sin 2 theta using this one. So cos 2 theta, sin 2 theta, when you replace them, next you just simplify. So if you multiply this one, we have cos square and we have another cos, so overall we will get cos cube theta, and then we need to multiply with minus 1. Similarly here we need to multiply each and every single term. So overall we have multiplication sign with in between them. So in short, we have 2 cos theta, and sin theta will give us sin square theta. Okay, so after this line we can see that we have this sin square theta, but we cannot keep this one because the overall thing has to be in terms of cos. So we can replace sin square using 1 minus cos square from this formula. Sin square plus cos square equals 1. So from here, if we subtract sin square, you will get 1 minus cos square. So this part is unchanged. Okay, this portion is unchanged. We just need to work with this one. So if you so this part is unchanged. When you multiply this one with 1, you will get 2 cos theta. But when you are multiplying with this last one, we have cos square and we have cos. So overall it's cos cube. Okay, so you just need to multiply this whole bracket with this one. So minus 2 minus will give us plus 2. Okay, then you just add them up. We have 2 cos cube theta. 2 plus 2 will give us 4, and cos theta minus 2 and minus 1. So overall this is minus 2 minus 1, it's minus 3. So that's the formula for cos 3 theta. 4 cos cube theta minus 3 cos theta. Next we have part D, where the range is given 0 to pi. 0 to pi as in 0 to 180. I will solve in terms of degree, and at the very last line I will convert them into the radian mode. So this is the equation. This is the equation, and as you can see we have cos theta, cos cube theta, and if it's multiplied together we could have, even if it's multiplied together we cannot solve. We have a 2 over here, right? So basically it's complicated. We need to replace them with simple terms, right? So if we compare this two equation, we have cos cube and cos theta. We have cos cube and cos theta. So it's the same thing, but the coefficients are different. If we compare this, the coefficients are different. Like this is 9 and 12, but this is 4 and 3. So it's like these two are multiple of 3. If we just factorize this thing, this is 3 cos theta and this is 4 cos cube theta, right? So if we just factorize this thing, you take 3 out of this thing, so you get 3 cos theta, 4 cos cube theta. So it's the same thing, 3 cos theta, 4 cos cube theta, but the problem is with the sign, right? With the sign, like 4 cos cube theta has to be positive and this one has to be negative, but in our case it's the opposite. We got this one as negative and this one is positive, right? So to reverse the sign, what we can do, we can just take minus 3 common. You just factorize and take minus 3. In that case this will be minus and that will be plus. Eventually it will look like this, right? So that's the thing. We will just replace this whole thing. We will just rearrange this whole thing so that we can replace this part with only cos 3 theta. Okay, so this is part D. This is part D. We have to solve from 0 to 180, 0 to 180, and that's the equation we need to work with. So we will use this cubic formula that we have proved in part C. Okay, so this box is here, and as you can see we have 9 and 12. So if we just factorize this whole thing, you just take minus 3 common. In that case it's minus 9, and since you are taking minus, so it will be plus. So 12 divided by this will give you 4. So minus 3 cos theta plus 4 cos theta. So as in 4 cos theta minus 3 cos theta, 4 cos theta minus 3 cos theta. So it's the same thing, right? It's just it's before it's, even if you just replace the position, it doesn't matter, right? So it's the same thing, positive 4 cos cube and negative 3 cos theta. Positive 4 cube, 4 cos cube, 4 cos cube theta and negative 3 cos theta. So we can replace these two terms by cos 3 theta only, right? So this entire bracket thing you can replace with cos 3 theta. So now this whole thing is basically cos 3 theta from the triple angle formula we have proved in part C. Okay, so minus 3 cos 3 theta equals to 2. This is our equation. So from here, if you just shift this minus 3, we get minus 2 by 3. So basic acute angle is basically 3 theta. So cos inverse of this, I am taking only the value instead of sign. Do not take the sign, that use that sign to select the quadrant. So I'm just taking the value cos inverse of 2 by 3. So this is the basic acute angle. And since it's all sine, tan, cos, and its cos negative. So cos positive is in first and fourth. Since it's negative, so we have to use second and third. So the formula for second quadrant is 180 minus theta. For third quadrant is 180 plus theta. Right? The different formulas were theta, 180 minus theta, 180 plus theta, 360 minus theta. So since we are working with the second and third quadrant, so these are the two formulas. So theta is 48.2. So if you replace it here, 180 minus 48.2 will give you this. 180 plus 48.2 will give you the second result. But then again, this was basically 0 to 180 was for theta, but we are working with 3 theta, right? So you multiply this range with 3. So 0 into 3 is 0. Theta into 3, 180 into 3 will give you 540. Yes, 540. So this is your range. Like you need to find the new range. So the range is from 0 to 540, and we have two values up to 200. So we can rotate. Like whenever we have a greater range, we just need to rotate. For every rotation, you need to add 360. So for the first angle after rotation, this will be 131.8 plus 360. I didn't use extra values. Like you could have added 360 with the second value, but that's actually 228.2 plus 360. That's actually 588 something. So that will be out of the range, right? The highest value has to be less than 540. So it's 588 out of the range. So that's why I didn't even bother writing that. So you can skip this one. So only the first value is rotated. You can rotate the second one, but that will be out of the range. Eventually you need to discard that one. Any value which is out of the range, you need to discard those. Okay, so two original values, and then after rotation you get the third one. So these are the values for 3 theta. Now you just divide by 3 to get the value for theta. Then again, the initial range was between pi, right? The initial range was in terms of radian. So to convert any values from degree to radian, you just need to multiply by pi by 180. So with these 3 values, I am just multiplying pi by 180, pi by 180, pi by 180. And then from calculator, you will just get this final 3 values. So this is part D. Okay, so this is part D. Next we will solve part E. So for part E, this is the equation. You need to integrate this thing. Okay, so for integration, we know that integration of sine theta is minus cos. Integration of cos theta is sine. This is for integration. Okay, so we can integrate sine or cos, but we can, for example, this one, we can integrate this one, right? Sine will be minus cos, but we cannot integrate cos cube. Whenever we have a power, we cannot integrate them. So for that, we need to replace them. Since we do not have the formula for cos cube cube theta, since we have a power here, we cannot integrate them, so we need to replace them. Okay, so we need to replace them from the triple angle formula, as in this one, this formula. In this formula we have cos cube theta, right? Like we need to integrate this part. For part E, we need to integrate this equation. So I'm okay with this, but I need to replace cos cube theta. So we can subject cos cube theta from this triple angle formula. Okay, if we subject from this formula and then replace that value here, only then we can integrate. So yeah, I will just start with, so this is part E. So this is the triple angle formula. Okay, cos 3 theta, it equals to this. This is what we have proved in part C. So from here I'm just going to subject cos cube theta so that I can replace it here. So in this line 4 cos cube, if I keep this one and shift it at the right side, this negative cos 3 theta will be positive cos 3 cos theta, sorry, 3 cos theta. And then since we need cos cube theta, so for cos cube theta you need to shift this 4, so it will be 1 by 4 of this whole thing, 1 by 4 of this. Okay, so now that I know the value for cos cube theta, I can just replace it here. So for part E, this is the question, integration of this. This is the question. So in this one, I will just replace this cos cube theta with this blue box. So here it is. Okay, so to integrate this one, I will just replace cos 3 theta, cos cube theta. So value of cos cube theta is this. So I will just replace it here, keeping each and every single thing as it is. Like you just need to replace this value and all the remaining terms will be same. Okay, so 3 is here, cos cube, instead of cos cube I just replace the formula we have got here. Then 2 sine theta is 2 sine theta. Then we have limits up pi by 2 and 0. Okay, so 3 into 1 by 4 is basically what? 3 into 1 by 4 is basically 3 by 4. So you need to multiply 3 by 4 to each of them. So 3 by 4 into this, 3 by 4 into this, 3 by 4 into this one, since we have a 3, so it will be 9 by 4. So we are done with this, and we have 2 sine theta here, 2 sine theta. Okay, now we can integrate. Cos theta is basically sine theta, like cos theta is sine theta, but whenever we have like a coefficient, suppose cos 2 theta, it will be sine 2 theta divided by 2. Like the coefficient, you need to divide this whole thing by the coefficient. So cos 3 theta will be sine 3 theta, but we have 3, so you need to divide this whole thing by 3. Cos theta will be sine theta will be minus cos, so here it is minus cos. Next 3 by 4, we have 3, so 3 4s are 12, or you can just cancel it out, you can use 1 by 4. When I solved this I used 3 by 12, so 3 by 12, but you can cancel it out. So 3 by 12 sine 3 theta, and these two are the same thing. So since we're done with the integration, I will just replace theta first with the upper limit. So in this bracket it's the same thing with values of theta, that's it. I just replaced each and every single theta with pi by 2, and in the second bracket it's the same thing with value of theta as 0. Okay, so upper limits minus lower limit. Terms with the upper limit, you can get the values from the calculator. This is minus 3 by 2, this whole thing is 9 by 4, this is 0. And for the second one, 3 into 0 is 0, so that's why sine 0 cos 0. So this is 0 0, 2 cos 0 is minus 2 cos 0 is minus 2. So from the calculator we'll get values for each and every single part, and you need to have the calculator in radian mode to get these values. If you use the calculator in degree mode, in that case you need to write 180 by 2. If you use the calculator in degree mode, you need to use 180 by 2. And if you just want to type pi by 2, pi in terms of pi, then you need to convert this into radian mode. Keep the calculator in radian mode. Okay, so this is the final result. So that's part D and E. And that's A, B, C. So this is the solution of this math.